Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju P. In this video, we are going to discuss about one more important question that is belongs to the canonical ensemble only. So, why I am teaching? Because the canonical ensemble 3 classes I uploaded in our YouTube channel, right? So, you have to listen this canonical ensemble. This canonical ensemble is very important. So, that is why I am giving to you. So many things, so many varieties of the things the question paper setter will ask to you. So, this is one of the variety to get the partition function under the canonical ensemble. CSIR June 2015 there was a question, a system of n non-interacting classical particles each of mass m is in a two-dimensional harmonic potential of the form V is equal to, that is the two-dimensional. Which one we have to write it is, you have to take it as a whatever the data they are giving, that data you have to write it is first. So, this system is in a two-dimensional system you have to take. So, that potential V of r is equal to alpha into x square plus y square. This is the potential where alpha is a positive constant. We need to calculate the canonical partition function of the system at temperature T is given by, they are asking the canonical partition function of the system. So, you know that, so what is the canonical partition function of the system, how we have to calculate? The system is two-dimensional, you know that. First you have to calculate the Hamiltonian of the function. So, what is the Hamiltonian is equal to I is equal to 1 to 2. So, Pi square is divided by 2m plus the potential energy V of r we have to write it is. So, what is your potential energy? Your H is equal to Hamiltonian H is equal to I is equal to 1 to 2. So, Pi square is divided by your potential is two-dimensional potential, that is alpha into x square plus y square. This is the potential. So, therefore, your H is equal to, so you have to remove this summation. So, p x square is divided by 2m. So, plus p y square is divided by 2m. So, plus alpha into x square plus y square, alpha into x square plus y square. This is the corresponding Hamiltonian. So, what is a, for a single particle canonical ensemble partition function is equal to, it is a classical particle. For a single particle, which one we have to write it is, for a single particle canonical ensemble partition function is equal to z1 is equal to 1 by h square into integral minus beta into h. So, d pi and so d qi you have to write it is. So, this value you have to substitute here. So, based on this your h is equal to, you know that. So, what is your h? So, the canonical partition function for a single particle is equal to 1 by h square into 1 by h square into e to the power of minus beta into, what is your Hamiltonian? Your Hamiltonian is px square is divided by 2m plus py square is divided by 2m plus alpha into x square plus y square, alpha into x square plus y square plus which one we have to write it is, that is dqi into dpi. Clear? So, this board is not sufficient for me. So, that is why I have to take it as a next page I am going to take. So, therefore, z1 is equal to, we are going to write it is 1 by h square into 1 by h square into integral minus infinite to plus infinite, the first one I am writing, minus beta into px square is divided by 2m minus beta into 2x square is divided by 2m into dpx I have to write. The next integral minus infinite to plus infinite e to the power of minus beta into py square, which one we have to write it is, py square is divided by 2m into dpy, py square into dpy. Integral minus infinite to plus infinite. So, e to the power of minus beta into alpha minus beta into, which one we have to write it is, alpha minus beta into alpha x square minus beta into alpha x square into dx. So, integral, one more integral you have to write, it is integral minus infinite to plus infinite minus beta into alpha y square into dy. So, this is the doing you have to do. You know the standard integration formula, integral minus infinite to plus infinite e to the power of minus ax square dx is equal to root phi by a. So, this is the formula I have to use. So, based on this formula, how we have to write it is z1 is equal to, again I am writing 1 by h square into integral minus infinite to plus infinite e to the power of minus p x square is divided by 2m into kt, 2m into kt into dpx. So, integral minus infinite to plus infinite e to the power of minus py square is divided by 2m into kt into dpy. So, integral minus infinite to plus infinite e to the power of minus alpha x square is divided by kt into dx. Integral minus infinite to plus infinite e to the power of minus alpha into y square is divided by kt into dy. You have to write this one, you are able to take. So, therefore, the canonical partition function for a single particle is equal to 1 by h square into 1 by h square into, you have to write here. So, based on that standard integral formula, how you able to take a square root of, you able to take it as a 1 by 2 m kt, that is the a value you have to write, you are going to get it as a 2 phi m kt. So, 2 phi m kt. So, you are going to take the denominator by denominator, it goes to the numerator, 2 phi m kt you are going to get it. So, is divided by phi by a is equal to, that is going to get it as this is also 2 phi m kt. So, 2 phi m kt you have to write, this one also you are going to take. Now, this one you have to write it is, so that is 5 is divided by, which one we have to write, it is phi kt is divided by alpha. So, this one also you have to take phi kt is divided by alpha, you have to write, this is the bracket close. So, but you know that, so you have to do it, it is 1 by h square into, so 2 into root 2 into 2 you are going to get. So, 5 that is phi square. So, kt whole square, more kt root kt root kt root kt root kt is there. So, now root alpha into alpha. So, now you are going to get it, so which one you are going to get? So, 2 phi square kt whole square is divided by alpha into h square. But you know that, so beta is equal to 1 by kt, you know that beta is equal to 1 by kt. So, therefore, what we have to write it is 1 by h square into 1 by h square into 2m phi square is divided by alpha into beta square, you have to write. So, therefore, so this is a single particle partition function. So, you have to take h is equal to 1 unit, you have to consider, this is the Planck constant. So, therefore, what we have to write it is 1 by 1 is equal to, you have to take it as a 1. So, therefore, you are going to get it as a, the single particle partition function is equal to, so 2 phi, so 2m phi square is divided by alpha beta square, you are going to get it. If n number of particles are existing, what is going to happen? So, the n number of particles, for n number of particles you have to take, for n particles you are going to take it as a, so that z n is equal to canonical partition function is equal to, so 2m phi square into alpha beta square whole to the power of n you are going to get. So, this is your answer. So, based on your problem you have to do this one. So, what is this answer? Once you have to take, your answer is option A is not correct, option B is not correct, option C is not correct, option D is correct. 2m phi square is divided by alpha beta square whole to the power of n is there. So, this is your answer. So, like this you able to get in your competitive examination. So, maybe how many marks they will ask? So, 3.5 marks they will ask. based on this question you have to see. This is very important question you able to remember in your competitive examination. Clear? So not only that, so we are informing you, we started CSIR and GATE physics content coaching. Already we finished 4 papers successfully. We finished so primary and secondary means core and advanced syllabus of CSIR. We have one app, that is Quantum Online Academy app is there. So first you have to download that app. After downloading your app, so you able to see the course CSIR and GATE physics content and JL physics content and DL physics content you have to see. So not only that, you able to see this individual courses also we started. We finished the mathematical methods of physics, we finished the classical mechanics, we finished the electromagnetic theory, we finished a quantum mechanics also. So we finished the thermodynamics, we finished. Now we started the statistical physics we are starting. So every day in our app, morning 6 a.m. to 8 a.m. there is a live class is going on. Every day morning 6 a.m. to 8 a.m. there is a live class. In the evening time also 7 p.m. to 8 p.m. 7 p.m. to 8 p.m. there is a live class is there. Every day morning 6 a.m. to 8 a.m. there is a live class. 7 p.m. to 8 p.m. there is a live class in app. For canvassing only, I am uploading the question solutions. Maybe you get the benefited, some people get the benefited these things. You have to listen and enjoy. So whatever it may be. So please share and subscribe and like our YouTube channel. You have to inform to your friends who are interested to do the a net set, whatever it may be, JL or DL or Polytechnic, any competitive exam after the masters. This syllabus is very essential. Clear? Once we finish this syllabus, how to start the UPSC mains physics content, how to start to you. So that is very important. Whoever aspirant for the mains exam for UPSC in the physics field, I want to teach that paper. Clear? So please listen and enjoy and inform to your friends. Thank you so much.